A very good afternoon to all our grade 12 learners. Welcome to today's lesson. My name is Mampani Kekana, and this lesson is brought to you by Gauteng Department of Education in collaboration with Siboney Discovery Center. So, boys and girls, welcome back again. Today, our focus will be on maps and plans, and then I hope you guys are ready. Remember, maps and plans. Okay. Right. Remember, maps and plans, boys and girls, will count for about 60 marks in paper 2. So please make sure that you ensure that you study and prepare yourself very well for this topic as well. It's going to count about 60 marks in paper 2. So today we're going to focus on maps and plans. The subtopic is scale and maps. Now, what is important in today's lesson is by the end of this lesson, you must be able to remember the following. I know that your educators have covered everything with you at school level, but we are just going to refresh your memory in terms of what has been covered at school level. But you must just remember the following. With this lesson, you must be able to work with number scale and bar scale. So you must know the difference between number scale and bar scale. And then you must also be able to interpret compass directions and use the compass to give directions. The third one is you must be able to write grid reference to identify locations in the maps or plans. And then you must be able to work with different types of maps or plans. You must also be able to calculate the actual length or distance on the map using bar scale or number scale. And then you must also be able to use given map or plan to find the way to the destination. The next point is you must be able to determine the scale in which a plan has been drawn in the form of 1:2. Okay, especially if you are given a number scale or a bar scale, you must be able to write it in the form of 1:2. And you must also be able to use the scale to determine other dimensions on the map. Okay, as you know, boys and girls, terminologies are very, very important in MathLead. You cannot be working with certain terminologies and you can't define them. If every day you are working with map, if they have to ask you to define map or explain what a map is, you must be able to explain it. But the other thing that is important with terminologies in MathLead is we do not expect learners to write exactly the same thing. If you look at the definition of any terminology and you read it once or you read it twice and you see that you can try to make it simple, just do it that way. So just make sure that you summarize or you make it as simple as possible so that you can remember it in the examination. So what do we mean by a map? For this one, it's a map is a diagrammatic representation of an area of land. So for this part, where we say a map is a diagrammatic representation of an area of land, I think this is actually enough for the definition. But in broad, a map is a diagrammatic representation of an area of land or sea showing physical features, that is cities versus national, provincial map, street chart, elevation map, and street map. But if you look at this definition, boys and girls, it's actually very long. So you can just summarize it and say a map is a diagrammatic representation of an area of land, and that will be more than enough. And then again, a map can be expressed as a plan or a chart. As I indicated at the beginning, boys and girls, that in MathLead terminologies are very, very important. So in these maps and plans, we'll be working with bar scales, elevation map, elevation plans, floor plans, street maps, number scale, route map, national road, regional road, and municipal road. But you must be able to explain this. explanations are very important, or the definitions are very, very important. Now you can think you have been working with bar scales on daily basis at your school level. The moment you see the word bar scale, there should be something that comes into your mind in terms of definition. Now, what is a bar scale? Now, a bar scale is bar scale it's diagrammatic picture that is divided into two or three equal parts. Two or three equal parts, and is used to measure map or plan. Okay, or it's a line that is divided into two or three parts, and that is used to measure map or plan. So that is the simple definition of bar scale. And then what about number scale? A number scale is a ratio that shows a ratio that shows the relation or the relationship between a drawn picture and a real diagram. Okay, so a number scale, it's a ratio. Remember, number scale, it's a ratio that shows the relationship between a drawn picture and a real diagram. In other words, it shows either how big or how small that picture it is in real life. Or a map, it shows how big or a map it is in real life. So that is a number scale. And then we've got an elevation map. An elevation map, it shows the heights. Remember, for instance, we know, for instance, Pretoria, it's a little bit lower than Johannesburg. So if you are probably at a certain place, you might see a certain place being higher, and then you might see certain places being lower. So in that case, we look at the elevation map. The elevation map, it means it's a map that shows the height, of places, above sea level or below sea level. Okay, it shows the height of places above sea level or below sea level. That is an elevation map. Then we've got an elevation plans. So elevation plans, the elevation shows the side views of a three-dimensional figure. three-dimensional figure. Like for instance, if we've got an elevation plan, if you've got a house, the side views of the house, that will be an elevation plan. And then we've got a floor plan. The floor plans, it's the view of a house from above. Okay, think about a house. Okay, think about the way you see the house from above, especially when the roof is removed. So the floor plan is the view of a house from above when the roof is removed. Okay, so the floor plan is the view of a house from above when the roof is removed. Then what about the street maps? What about the street maps? The street maps, it's so for the street maps, we've got a route that shows okay, okay, sorry about that. The street map is the map. It's the map of a town or city showing locations of places, and names of streets. Okay, street map. So the street maps is a map of a town or city showing location of places and names of streets. Then we've got the next one, is a route map. Now a route map shows the main roads. It shows the main roads used by, let's say for instance, by buses or trucks or cars. So for instance, if you have to travel from Johannesburg, you have to travel from Johannesburg to Durban, which routes are you going to use as the driver? Okay, so the route map will clearly show the main routes, the main routes that must be used by a driver when driving a truck, buses, or a car. So, and then we've got again a national road. Now, think about national road. In South Africa, we've got different or many national roads. Like for instance, the most popular one is N1. And then we've got N12, and then we've got N14. We've got N3. If you think about N1, it starts from Limpopo all the way to Cape. So the national road, we can say it's a road that connect major cities or provinces. Okay, it's a road that connects major cities or provinces. Then we've got the regional route. Now, if you check around your area, you might have seen the roads that are indicated with letter R. Like for instance, if you are staying in Soshanguve, you'll have a road like R80, which is from Soshanguve or from Mopani to Pretoria. And then again R59, which is a road from Johannesburg to Vaal. So think about those roads. So a regional road, it's a road that connects places in a province. In a province. It's a road that connects places in a province, or it's a place, or it's a road that connects small towns. In other words, from small town to a small town, or maybe, for instance, it connects a township and the city. So, but it's a road that connects places in the very same province. And then we've got municipal road. Municipal road, it's a road that connects places in a city. Like, for instance, in Johannesburg, we've got M1. Which will be from Sandton to the CBD. Okay, so municipal road, it's a road that connects. A municipal road is a road that connects places in a city. In a city, or you can say municipality. Okay, so that is more or less. Remember, boys and girls, if you look at these terminologies, these are not cutting stones. It does not mean that these are the final, or you have to take them exactly as they are. Once you see any terminology and then you read it once, you are welcome to come up with your own version of that terminology, as long as it is relevant. So these are some of the terminologies that you must know, especially in maps and plans. So in this case, I've covered all the terminologies, all the possible terminologies that you can get under maps and plans. Okay, then here we've got an example of number scale and bar scale. If you look at the first one, is number scales can be expressed in a ratio form. The first one, we've got 1:500, or we've got 20:1. So it means it's possible that the number on the left-hand side, it's smaller than the number on the right-hand side. If it's 1:500, it means the picture or the map that is given is 500 times smaller than what it is in reality. Think about the map of South Africa. If you see it on a paper, you will see that the map has been reduced. So in other words, you'll find that that map is probably about 500 times smaller than what it is in reality. And then it is also possible that the scale can be written other way around, where the number on the left-hand side is bigger than the number on the right-hand side. So it means if the number on the left-hand side is bigger than the number on the right-hand side, it means the picture has been enlarged. Okay? Think about those who are doing life sciences. They will know that, for instance, if they are working with insects, some insects are very, very, very small in such a way that you cannot see them with the naked eye. So what they will do, or the viruses, they cannot be seen with the naked eye. So what they will do is they will have to enlarge them to put them on a picture or to put them in the book. So in that case, they will indicate that this picture has been enlarged. So it means it is 20 times bigger than what it is in reality. In other words, it has been reduced. Then we've got linear graphic, which is a bar scale. I think we've already spoken about this one, but the definition is a bar scale is a linear graphic that is divided into equal parts and used to measure distances on map. Linear graphic that is divided into equal parts and used to measure distance on maps. So if you are given a bar like this one, it means what you need to do, you must measure it. You must measure it. You can see that this is from 0 to 20 meters. From 0 to 20 meters. So what you need to do is you have to use a ruler, and please make sure that for this section, boys and girls, you always have a ruler with you and a pencil. So we've got 0 to 20. Then you need to measure it with a ruler, either in centimeters or millimeters. So if I look at the one that is given here, if I measure it in millimeters, I'll get about 40 millimeters. So what does this mean? 40 millimeters, it means 40 millimeters is the same as 20 meters in reality. So 40 millimeters is the same as 20 meters in reality, or you can write it in ratio form. 40 millimeters is to 20 meters. 20 meters. Then how do you simplify this? In order to simplify, you must make sure that the units are the same. We've got 40 millimeters, which is, how do we convert from meters to millimeters? How do we convert from meters to millimeters? Think about it. Conversion, we have to multiply by 1,000. So this will become 20,000 millimeters. Okay, then how do you simplify? You divide by 40 millimeters. You divide by 40 millimeters. And then this will give you 1 is 2. 40 divided by 40 is 1. The millimeter and millimeter will cancel out. Then we've got 20,000 divided by 40. So it's very important. You must use your calculator. You say 20,000 divided by 40, and then this will give us 500. Okay, so whenever you're given a bar scale, it means you must be able to measure it. Okay, you can measure it from 0 to 10, but we advise learners to always measure it from the starting point to the end point, just to make it easier for yourself. So from the starting point until the end point, in this case, if I measure from this point to the other point, I get 40 millimeters. So it means 40 millimeters on the map is the same as 20 meters in reality. And then this is how I simplify it. 40 millimeters is to 20 meters. Then I have to make the units to be the same. This one is in meters. I multiply it by 1,000 to convert it to millimeters. Then we divide by 40. We divide by 40, and then we get 1 is to 500. Then remember, with a scale, there's no unit. It's now in simplified form. Okay, then the other thing that is very important, boys and girls, under maps and plans, is compass. Okay, the cardinal points of a compass are very, very important. In MathsLead, we are using 8 cardinal points. 8 cardinal points, that is north, northeast, east, southeast, south, southwest, west, and northwest. But we know that in most cases in the examination, they don't give you all the 8 cardinal points. The examiner would only give you, for instance, north. And then you must be able to complete that cardinal points. If the north is facing up, we know that the right-hand side is east, the left-hand side is west, and then at the bottom there it's south. And then between north and east is northeast, between south and east is southeast, between south and west is southwest, and between north and west is southwest. But the other thing that is very important with regard to the compass is it is not always facing up. The arrow will not always face up. The examiner might decide to show north facing this direction. So everything else is going to change. We always advise learners that if the direction of N changes, you need to turn your question paper as well. You need to turn the question paper up so that you can see, you can be able to complete the compass. So if the north is facing to the left-hand side, it simply means this side is going to be east, okay, and then this side is going to be west, and then this side is going to be south. Okay, you know the rhyme with regard to the compass, it's never ever smoke weed. So in this case, you'll be able to complete your compass. Now, compass directions are very important when describing one's position, or if you want to describe a position of a house or a place. Okay, A compass has four main directions, as I indicated. We've got north, south, east, and west. And then four more directions that are between or are in between. In this case, we've got northwest, northeast, southwest, and southeast. Then to find a location using directional indicators such as, in some cases, the examiner would say, describe a direction. Describe a direction on how to get to a certain place. Now, if you describe, please remember to indicate the following or use the following. Left, so it means if a person must turn left, make sure that you indicate that you follow the route and then you turn left, or you turn right, or you drive along, or you drive straight, or you drive up, down. For example, you must indicate turn left or turn right. Okay, so in this case, when you describe a direction on how to get to a place, please make use of this. Unless if you are sure about the compass direction, you are sure that this is indeed east, you can also indicate 10 east, or you can indicate 10 north, or you can indicate 10 south, as long as you are sure that that direction is correct or it's accurate. Okay, so as I indicated, you can also use north, you can also use south, you can also use east, west, and so on. So that means you can say 10 to the north, or 10 to the east, 10 to the south, or 10 to the west. The same thing with northeast, northwest, southeast, and southwest. Then the next one is you must be sure to orientate the map for the direction in which you are traveling so that you give correct direction. Orientate simply means if an arrow of north is facing, let's say for instance down, you must be able to turn it around and make sure that it faces up. Okay, make sure that it faces up so that you'll be able to complete your compass direction. Then the next one is mark your selected route on the map or plan to make sure that you do not miss out on any details. So that means when you look at the map, if they say describe a direction from one point to another point, describe a direction from one point to another point, what you must do is you must just use maybe a pencil to indicate the route before you can explain. Just indicate with a pencil that I'm going to move from this place to the next place. Then from there, you'll be able to follow your route using a pencil. So that is very important, that you must mark your selected route. Then again, you must be able to use turn left or turn right. And then again, what is important is, boys and girls, you must also be able to give the names of the streets. Think about the real life. Whenever you give someone a direction, these are some of the ways that you have to use. You have to use either turn left or turn right, and then maybe if you know the names of the streets, then you also mention the name of the streets. When they say describe the direction, please make use of an information or as much information as possible. So that is very important. So the names of the streets must also be indicated where possible. Okay, then we've got the typical exam questions. These are the questions that were taken from previous question papers or various question papers. Okay, so this one was taken from IEB November 2020 paper 1, and that was question 3. The question is, Pilgrim's Rest is a small museum town in Mpumalanga, South Africa, which is protected as a provincial heritage site. It was the second of the Transvaal gold fields, attracting a rush of prospectors in 1873, soon after the Macmac diggings started some 5 kilometers, and that is 3.1 miles away. Use the map above to answer the questions that follow. Use the map above to answer the questions that follow. So remember, boys and girls, in Maths Lit, reading is part and parcel of a question paper. So the allocated time in a question paper is also for reading. Even if you have to read an information more than once, please make sure that you read it so that you understand the given information. Right, now the first question is, of course, use the map above to answer the questions that follow. 1.1, give the grid reference for Joubert Bridge. Give the grid reference of Joubert. Now the grid reference, boys and girls, is if you look at this map that is given, it consists of blocks. So you've got 1, 2, 3, 4, 5, 6 blocks sideways, and you've got 1, 2, 3, 4, 5 blocks going down. So when they say a grid reference, they want to know in which block do you find Joubert Bridge? In which block do you find Joubert Bridge? That is the grid reference. Okay, now if you look at the name of the place, which is Joubert Bridge, the Joubert Bridge is in this block. Okay, so in this block, if you look at this, you can say it's block number 3. Okay, you can say it's block number 3 because again there are many block number 3s there. So this one is 3, this one is 3, this one is 3, this one is 3, this one is 3. But again, if you look at this one, can you say this is B? Yes, but you can't just say it's B only because this is B, this is B, this is B, this is B, and this is also B. So it means you need to specify which block is Joubert Bridge. So in this case, it means you're going to say it's B3. It's in block number B3, and that is the grid reference for, or the grid reference of Joubert Bridge. Right. The next question is, by making use of the bar scale, calculate the area of B5 in square meters. By making use of the bar scale, calculate the area of B5 in square meters. Right, now we need to understand the area of B5. B5 is this block. No, sorry, it's this one. The one that shows Caravan Park. That is B5. They want us to calculate the area of this block. If you look at the shape of the block, it's actually a square, or it's more or less a square, but we need to do the measurement just to be sure that indeed it's a square. Right, but the dimensions are not indicated. The dimensions are not indicated. So it means we need to measure the length and the breadth, of the block. Okay, so in order to measure the length, you have to make use of a ruler. So if I take my ruler, then I measure, I get about 15 millimeters. So with a side, okay, side 1, it's 15 millimeters. Okay, and then I'll also have to check the other side. Remember, at the beginning, I said it looks like a rectangle, but we need to confirm that. I mean, it looks like a square, so we need to confirm that. So if I measure the other side, I still get 15 millimeters. So side 2, it's also 15 millimeters. So it means this is a square. Right, but if you look at the question says calculate the area of B5 in square meters by making use of the bar. So it means these are the measured values on the map, but what are the real measurements? What are the real measurements? To get the real measurement, it means I have to use the bar scale. If you look at the bar scale, it shows from 0 to 600 meters. 0 to 600 meters. So if I measure the length of the bar scale in millimeters, okay, if I measure it, I also get 15. So it means 15 millimeters. It's actually the same as 600 meters. in reality. That 15 millimeters, according to the bar scale, it is indicated that the length of the bar scale is 600 millimeters. But when I measure it with a ruler, I get 15. So it means 15 millimeters is equal to 600 millimeters. Okay. Then it means in reality, the side 1 is 15 millimeters. Side 2 is 15 millimeters. So it means in this case, I can just immediately say this is also 600 meters and this one is also 600 meters. Okay, I know that we are supposed to do the cross multiplication and so on, but from the measurement, we can clearly tell that according to the bar scale, the length of the bar scale is 15 millimeters, which is 600. But when I measure the length of each side, I get 15 millimeters. So what does that mean? It means automatically the length of the cell, the length of or each side of the cell or each side of the block is it's 600 millimeters. So how do I calculate the area? The area is now 600 multiplied by 600. Okay, you can indicate the unit if you want to, but we've got 600 meters multiplied by 600 meters. If I do it on my calculator, I've got 600 multiplied by 600. Then this will give me 360,000 meters squared. 360,000 meters squared. This is how we do it. Okay. Now, remember, if I had to find different measurements in this case, I would not automatically say that 15 millimeters is equal to 600. It simply means the length of the bar scale is the same as the length of each block. Is the same as the length of each block. So that is why I'm saying if the length of the bar scale is 15 millimeters, but in reality 600 millimeters, therefore, for the one side of the block is 15 millimeters and it is also 600 meters. And the side 2 is 15 millimeters, it is 600 meters in reality. So therefore, I can just take the real dimensions, I multiply them together. Then this will give me 360,000 meters squared. And then that is question number 1.2. Right, then the next question, 1.3, name the tourist attraction indicated by a star that lies south of the Stowe Museum. Name the tourist attraction indicated by a star that lies south of the Stowe Museum. South of the Stowe Museum. Now, what does this mean? We have to look for our compass. Okay, we have to look for our compass. Now, where is our compass on the map? Okay, if I check around, there is the compass. It shows that N is facing up. So N is facing up. So if I complete the compass direction, this will be east, this will be west, and this will be south. So we've got north, east, south, and west. And then if you want to, you can complete and say this is northeast, this is southeast, and this is southwest, and then this is northwest. Okay, depending on whether you're going to need those directions or what. The question says, that lies south of the Stowe Museum. The Stowe Museum is in D4. So let's look at D4. There's the D4. Okay, but they say it lies south. So south is here by the star. Okay, indicated by the star. So this one is Robert's grave. So it's Robert's grave. Okay. So that is the answer for number 1.3. We just had to look. They say south of the Stowe Museum. So this is the Stowe Museum. And then to the south, okay, so that is Robert's grave. Then 1.4. It's Pilgrim's Rest covers a total of 25.4 kilometers squared, 25.4 square kilometers, and is home to 1,721 people. Determine the number of people per square meter. Determine the number of people per square meter. Now remember, if you have to determine the number of people per square meter, think about this. If you've got kilometers per hour, I'm just giving an example, or you've got the rands per liter, it means you can only get kilometers per hour by dividing the number of kilometers with the number of hours. To get the rands per liter, you have to take the amount of rands and then divide it by the number of liters. So once we say kilometer per hour, it means to get this, we'll have to divide kilometers by the number, or the number of kilometers by the number of hours. And then to get the rands per liter, we have to divide the amount of rands by the number of liters. So to get the number of people per kilometer squared, it means we have to take the number of people and divide it by the number of square kilometers. We have to take the number of people and divide it by the number of square kilometers. So what is the number of people? The number of people is 1,721. Then we divide it by, so this one is 1,721 people. Then we divide it by square meters, which is 25.4 kilometers squared. 25.4 kilometers squared. Then the answer is, if you take your calculator, 1,721, you divide it by 25.4, you must get 67.75, 67.7559, and so on and so on. Then we say this is the number of people per square meter. So actually it will be 67.7559, and then it's people per square meter. Right, now remember again, in terms of rounding, the number of people cannot be in decimal form. Remember, in this case, the examiner would not indicate to you that the number of people must be rounded off. It's something that you must know. So in this case, if we've got 67.75, we can finally say the number is 67 people per kilometer squared. 67 people per kilometer squared. So you don't leave your answer in decimal form, because this decimal means is the number of people, and then we can't leave the number of people in decimal form. We don't get a fraction of a person. So in the end, it must be 67 people per kilometer squared. That is number 1.4. Okay, the next question is another typical exam question. This one was taken from IEB November 2022, paper 2, question 4. So it's the picture alongside shows map of South Africa. Use the picture to answer the questions that follow. 2.1, Upington lies in the northern, western, eastern Cape. Then they say underline the correct province. Upington lies in the northern, western, eastern Cape, and then underline the correct province. So if you look at the map of South Africa, okay, we're looking for Upington. Here is Upington. Okay, then if you look at the province, you will see that Upington is in Northern Cape. So it means for this one, if we have to underline the correct answer will be Northern. Okay, all of them are Western. We've got Western, we've got Eastern, and it's Cape. So this means the answer will be Northern Cape. Just by underlining Northern, it means you say the answer is Northern Cape. So that is the answer for 2.1. Upington is in Northern Cape. Right. Then the next question, in which general direction does Kimberley lie from Johannesburg? In which general direction does Kimberley lie from Johannesburg? Now we have to look for our compass. Okay, if we look around the map, there it's our compass. There it's our compass. It shows north, it shows east, it shows south and west. And then they say, in which general direction does Kimberley lie from Johannesburg? It means if we are in Johannesburg, where is Kimberley? If we are in Johannesburg, where is Kimberley? So you can see that from this today. So this is from Johannesburg to Kimberley. So if I'm in Johannesburg, this is where I'm going to point where Kimberley is. So according to the compass, you can see that if I complete this from Johannesburg, it means I've got north, I've got south, I've got east, I've got west. Then you can see that it's between south and west. So I'm going to point Kimberley as between south and west. So therefore the answer is southwest. Okay, you can just write SW or you write southwest in full. Okay, then the next question, number 2.3, it's use the given scale. Calculate the distance as crow flies from Johannesburg to Kimberley. Use the given scale, calculate the distance as the crow flies from Johannesburg to Kimberley. So very important, crow flies. We all know that if you have to travel from Johannesburg to Kimberley, the route it's not straight. The route to get to Kimberley, it's not straight. Okay, so if we have to measure, if we have to follow the route, it means we will not be able to use a ruler. So, but in this case, they say as the crow flies. The crow flies, it means it's a direct distance. It's a direct distance from one point to the next. So what we have to do here is we have to measure a direct distance from Johannesburg to Kimberley. Right. Then what are we going to use? What type of scale is given in this case? The scale that is given is a bar scale. There is our bar scale. There is our bar scale. So we need to start by measuring the bar scale, or you can start by measuring the distance between Johannesburg and Kimberley. If you measure between the distance between Kimberley and Johannesburg, if I use my ruler, I'm getting about 29 millimeters. So it's 29 millimeters is what I'm getting. So that is the measured distance between Johannesburg and Kimberley using a ruler. Okay, but how am I going to change this to be a real distance? Then I go and look at my bar scale. If I measure the bar scale, okay, if I measure the bar scale, I get also about 29 millimeters. So it means 29 millimeters. That is the bar scale. 29 millimeters on the bar scale, it means is the same as 300 kilometers. Okay. Okay, when I measure the length of the bar scale from one point to the other point, I'm getting 29 millimeters. But on the bar scale, they have indicated that this is 300 kilometers. So I get 29 millimeters is the same as 300 kilometers in reality. So now, if I measure the distance between Johannesburg and Kimberley, and then I want to convert it to a real distance, what am I going to get? Can you see that these two are equal? 29, 29. So it means coincidentally, in this case, the length of the bar scale is the same as the length from Johannesburg to Kimberley. Right. So in this case, if you want to confirm it and do cross multiplication, you can still say, but this is 29 millimeters. And then what is our distance? But you will see that when you do the calculation, the distance will still be 300, because you're going to get d multiplied by 29, you get 29d, and you get 29 multiplied by 300. Okay, we can just do it. I know that the previous one that we did, we just took it as is, since the measurements were the same. But in this case, let us confirm if indeed our distance will still be 300 kilometers. If I cross multiply, I get 29d equals to, if I take 300, I multiply by 29, it gives me 8,700. And then to find the value of d, I divide by 29, divide by 29, and then this will give me the distance. 8,700 divided by 29, it still gives me 300. So it means indeed the distance is about 300 kilometers. So the distance between Johannesburg and Kimberley, it's 300 kilometers as the crow flies. So that was the answer for number 2.3. Then question 2.4. It is the continuation of the previous question. This one we've got the delivery truck travels the 505.5 kilometers from Johannesburg to Kimberley at a speed of 98 kilometers per hour. Okay. Now, when we did the calculations in the previous question, according to the map that is given, and then again, the direct distance is 300. So we're going to forget about that one. We move on to the next question. According to this question, the actual distance is 505.5 kilometers. Okay. That is from Johannesburg to Kimberley at a speed of 98 kilometers per hour. Determine the time the truck will arrive in Kimberley if it left Johannesburg at 9 o'clock. Give your answer to the nearest minute. Give your answer to the nearest minute. It means the minutes must be rounded off in the format of HHMM. So it means the time must be in hours and minutes. So you must indicate the time, okay, in hours and also in minutes. Okay, so where do we start? Remember, in this case, they say determine the truck will arrive in Kimberley. So we have to indicate the time. At what time are they going to arrive? So obviously the time will have to indicate the hours and the minutes. If it's 10 past 9, we have to indicate 10 minutes past 9. So we have to calculate what? In this case, we have to calculate time. Right, so how do we calculate time? Now remember the formula for calculating the relationship between distance, speed, and time. So we've got speed is distance over time. Speed is equals to distance over time. So that means if we want to calculate speed, we're going to take distance, we divide it by time. If we want to calculate time, we're going to take distance, we divide it by speed. Okay, and then if we want to calculate distance, we take speed, we multiply by time. So in this case, we have to calculate time. Then if we calculate time, we're going to say time is equals to distance, which is 505.5 over 98. Okay, our distance is in kilometers, our speed is in kilometers per hour. So that means our time will be in hours. Okay, so this one is equals to, if you take your calculator, you say 505.5 divided by 98, then this will give us 5,1, 5,163. Okay, remember, boys and girls, you are not actually supposed to round off until you get to the final answer. So this one is 5,158,163, and then we've got 265. Please check with your calculator as well. 5,158,163 8163.265. Now, if you look at the format of the time, we've got 5 hours. So the time is 5 hours and a couple of minutes. The most common mistake that learners are making here is once they see 5 hours and then they see the first 2 digits after the comma, they tend to think that the first 2 digits after the comma are the minutes, right? Like for instance, if I give you an example, if we've got 2,5 of an hour, okay, if they say write this in hours and minutes, write this in hours and minutes, so automatically you know that this is 2 hours. But that 5 after the comma, does it mean it's 5 minutes? No, it doesn't mean it's 5 minutes. It means it's a fraction of an hour. And that fraction of an hour is 0,5. So it means in this case, we've got 2 hours plus 0,5 of an hour. Then that 0,5 of an hour, we now need to convert it to minutes. And that is why 2.5 hours is the same as, if you take 0,5, you multiply by 60, then you get 30 minutes. So it means 2.5 hours. It's not 2 hours and 5 minutes, but it's 2 hours and 30 minutes. So we are splitting the whole and the fraction. Even if I can give you, for this, again, if I say 2,45 of an hour, let me make it 3. 3,45 of an hour. Then they say, write this in hours and minutes. Then you are not going to say this is 3 hours and 45 minutes. That comma 45 after the comma does not mean is the number of minutes. You still have to split it. You still have to say this is 3 hours plus a fraction. That fraction is 0,45 of an hour. Okay? Then we've got 3 hours plus a fraction of an hour. That fraction is. Now, how do you convert this? How do you convert hours to minutes? You say 0,45 multiplied by 60. If you take your calculator, you say 0,45 multiplied by 60, then it's going to give you 27. So it means this is 3 hours and 27 minutes. Okay, so this one, I was just giving an example in terms of a fraction, whenever a duration is given in the form of a fraction. Now, let's go back to this one, where we've got 5 hours. Okay, so we're going to split. We've got exactly 5 hours. Then we say plus. The whole fraction after the comma, it's the number of hours. Okay, then we convert that fraction to minutes. So if we've got 5 hours plus 0.158163.265, which is an hour, it's a fraction of an hour. So it means this fraction, we must now convert it to minutes. We have to take the whole fraction as is, we multiply by 60. Then if you take 0.158.163.265, okay, then you take the whole fraction or all the digits, you multiply them by 60. Then if I multiply by 60, I get 9.48. So this is 5 hours plus 9.489 minutes. Okay, so I've got 5 hours plus 9.489. So if I've got 5 hours and I've got 9.489 minutes, according to the instruction, it says give your answer to the nearest minute. 9.489, it means it's not exactly 9 minutes. It's 9 minutes and a couple of seconds. So if I had to convert the decimal to seconds, I'll split it again. But in this case, likely they say I must now round off the minutes. So if I've got 9.489 minutes and then I round it off, this will be about 5 hours. Okay, if we round it off 9.489, this will be about 10 minutes. So it's 5 hours and 10 minutes. Okay, so 5 hours and 10 minutes. Okay, so it means the truck will take about 5 hours and 10 minutes to travel from Kimberley to Johannesburg. Okay, actually it's from Johannesburg to Kimberley. So it's going to take 5 hours and 10 minutes. If it's going to leave at 9 o'clock, then I have to add 5 hours. So I say plus 5 hours and 10 minutes. Now think about this. 9 hours plus 5 hours is going to give me 14. Or 9 hours, 5 hours later is going to be 14. So it means it's going to be at 2 o'clock. So it's going to be 14 and then 10 minutes. Okay, so it means in the end, the time will be 14:10. Okay, it's going to be 14:10. So it's 10 minutes past 2. Okay, 10 minutes past 2 in the afternoon, or it's 14:10. Okay, sorry about that. Okay, now boys and girls, that is the answer for that question. We're going to take about 1 minute break and then stay tuned. Okay, welcome back, boys and girls. I hope you are busy calculating as well and you are also getting the same answers. Remember, it's very, very important that as we are busy calculating, you are also testing your calculator if it's giving you the correct answers. That is very, very, very important. So make sure that you also make use of your calculator to see if you are getting the same answers. Right, this was number 2.4. So the next question is still on the very same question taken from IAB November 2022. They say on the return journey, the truck takes 3 hours 20 minutes to complete the trip. Determine the speed of the return journey. On the return journey, the truck takes 3 hours 20 minutes to complete the trip. Determine the speed of the return journey. Okay, now it's a different story now. But the formula is still the same. The formula for calculating the relationship between speed, distance, and time, there it is. Now we need to calculate the speed. The speed is distance over time. So you can write it down. Speed is equals to distance over time. Our distance obviously is going to be the same. Okay? Our distance obviously is going to be the same. Remember in the previous question, there is our distance 505,5. It can be a different distance now. So our distance is 505.5 kilometers. Then we need to divide. We need to divide by time. But if you look at our time, it's given in 2 units. It's given in 3 hours and 20 minutes. But in this case, you can't substitute the time that is given in 2 units. You can't substitute 3 hours and 20 minutes. The time or the duration must be in 1 unit. And we know that speed of trucks are measured in kilometers per hour. So it means to get the speed here, to get kilometer per hour, we have to make sure that our duration is in hours. If we've got 3 hours and 20 minutes, how do we convert it? We've got 3 hours and 20 minutes. So it's plus 20 minutes. Those 20 minutes, we need to convert it to hours. The 20 minutes, we need to convert it to hours. Now we know that 20 minutes do not make an hour, but they make a fraction of an hour. So what we do is we say 3 hours plus 20 divided by 60. Once we divide by 60, it becomes hours. So we say 3 hours plus, if you say 20 divided by 60, you say 20 divided by 60. So that will give us about 0.33. So this is 0.3333 of an hour. So it means in the end we get 3 hours, total hours is 3.3333 hours. All those digits after the comma. So we had to convert because we could not substitute 3 hours. It would not make sense, boys and girls. It would not make sense that we substitute 3 hours and 20 minutes there. We can only substitute the duration that has got 1 unit. So in this case, we're going to say 3.333, as many digits as possible, because we're not supposed to round off until the final answer. Okay, so we've got 505.5. We divided by 3.33333. Then if you use your calculator, it's 505.5 divided by 0.3333. Sorry, 3.333. So 505.5 divided by 3.333333. And it gives me about 151. So it's 151.65. Then it's kilometers per hour. Okay, so the speed was 151.65 kilometers per hour. The examiner doesn't specify the rounding. If you want to round it off, you're also welcome to round it off, but you have to make sure that you round it off correctly. So in this case, if it's 151.65, you can still say this is about 152 kilometers per hour. 152 kilometers per hour. That will be the rounded off value. 152 kilometers per hour. That is how we calculate it. But what was important in this case was we had to convert the 20 minutes. We converted to hours. Very, very important. Okay, then the next question, boys and girls, it's a typical exam question 3. This was taken from KZN September 2022, and it was paper 2, question 5. So the map of Qatar and surrounding countries is shown alongside. Use the information on the map to answer the questions that follow. 3.1, name the capital of Bahrain as shown on the map. Okay, name the capital of Bahrain as shown on the map. Okay, then how are we going to know which one is a capital? How do we know which one is a capital? You must always check on your map. So if you look on this map, of course, we've got a compass, we've got names of places, and then, but we also have symbols that are indicated here. There we've got a line, okay? So if you see this line on the map, you must know that it shows an international boundary. Okay, so in other words, it's a border of the two countries. And then we've got a symbol for road, we've got a symbol for minor road, we've got a star for national capital, we've got a dot for city or town, and then of course we've got a bar scale there. So if we're looking for a capital, it means we must look for something that has got a star. We must look for a star. Name the capital of Bahrain. So where is Bahrain? They're up there, here. And then the star represents the capital. So the capital in this case is Manama. So it was just a matter of interpreting the symbols that are given. The symbols will tell you what each name represents. So in this case, Manama is the capital city. Okay, that was number 3.1. And then number 3.2, which area lies southwest of Doha? Which area lies southwest of Doha? Then now it means we need to know, or we need to check our compass. There is our compass with 4 cardinal points. Okay, north is indicated, east is indicated, south is indicated, and west is indicated. Then we look for Doha. Then there is Doha. It's just another name for at Doha. Doha, in this case, they say at Doha, or another name or another way of writing it is just DOHA. Which area lies southwest? Now, if Doha is here, okay, and then we know we've got north, we've got east, we've got south, we've got west. So actually it must be here. It's going to be much better if you draw it here. So it's going to be north, we've got south, we've got east, we've got west. Then we want to know somewhere here. Okay, it says southwest. So southwest is between south and west. Which area lies southwest? So between south and west, you can see that it's as Salwa. Okay, so this one is as Salwa. Okay, it's indicated there. That is the area that is between south and west. So it means it's in the southwest. Okay, then the next question is identify the type of scale on this map. Identify the type of scale on this map. So the type of scale we have to check. So if you look at this, there is the scale that is indicated. The scale is a bar scale. Bar scale, or you can say this is a linear scale. Bar scale or linear scale. So it's as easy as that. You just have to identify the type of scale on this map, then you indicate the name, it's a bar scale. The next question is convert this scale to a number scale. Convert the scale that you mentioned in the previous question, of which we said it's a bar scale. Convert this scale to a number scale. Write it in the form 1:2. Then if you look at the scale is given. Boys and girls, we need to be careful there. If you look at the scale that is given, there are 2 units that are indicated. We've got 2 units that are indicated. You see, we've got 50, but this one is 50 kilometers. We've got another 50, but this one is 50 miles. But we can only work with 1 unit. Okay, preferably the local unit. So what we're going to do is we have to measure the length of the scale from 0 until 50 kilometers. We measure the length of the bar scale from 0 until 50 kilometers. If I take my ruler and then I measure the length from 0 to 50 kilometers, I get about 10, 11, 12. I get 12 millimeters. Okay, I'm getting 12 millimeters. So after measuring, it means the 12 millimeters is the same as 50 kilometers in reality. Okay, 12 millimeters is the same as 50 kilometers in reality. But they say I must write it in the form of 1. So it means it must start with 1. Now, after we have indicated that 12 millimeters is equals to 50 kilometers as indicated, we need to simplify this. But we know that in order to simplify a ratio, the units must be the same. So for the units to be the same, we need to convert. Preferably, we convert the big unit to a small unit. So we can say 12 millimeters is to, how do we convert from kilometer to millimeter? Okay, you need to know your conversion table. How do we convert from kilometers to millimeters? Then we know that if we want to convert from kilometers to millimeters, we need to multiply. So we're going to multiply. We multiply by 1 million. So this will be 50 times 1 million. Okay, so it's 50 times 1 million and it becomes millimeters. So this will give us 12 millimeters is to 50 million millimeters. Okay, now the units are the same. We just had to convert. Initially, the units were not the same. So now we need to convert. 12 millimeters, obviously 12 millimeter, and the millimeter and the millimeter will cancel out. Then now we divide. We want to have 1. If we've got 1, you say 12 divided by 12. And then that 1 divided by 12. Then this one we're going to get 1 is 2. Use your calculator. 50 million, so it's 50 and 6 zeros. We divide it by 12. Okay, I'm getting so it's 1 2 3 4 5 6, so it's 4,166,666. Okay, 666,67. Okay, so when I divide 50 million, I divide it by 12, then I get 4,166,666,67. Again, the examiner might specify that you round it off to the nearest whole number. Okay, so in this case, if we round it off, the answer can be 1 is to 4,166,667. That is if we round it off to the nearest whole number. So it simply means the map is actually 4 million times smaller than what it is in reality. So this will be our scale. Right. Then this is the answer for number 3.4. Okay, then the next question is 3.5. Is based on the very same map. It says a tour guide stated that Al Kahwa is 45 kilometers away from Doha. A tour guide stated that Al Kahwa is 45 kilometers away from Doha. Verify showing all calculations if this statement is true. Verify showing all calculations if this statement is true. Okay, now what we need to do is we know our scale now. Okay, we know our scale. So if I take you back to this one, we can see that we've got 12 millimeters is the same as 50 kilometers in reality. 12 millimeters is the same as 50 kilometers in reality. Or you can still use the simplified scale. Okay, either you're going to use the measurement or you're going to use the simplified scale. It does not matter. Okay, but I think in this case, it's easier if you use 12 millimeters is the same as 50 kilometers. We know that from the measured bar, 12 millimeters is the same as 50 kilometers in reality. Okay, now we need to measure this. From Al Kahwa from Al-Khawar, and the distance between the two places, Al-Khawar and Doha, we need to measure it using a ruler. So if I take a ruler, I'll look for the places. So the place is Doha, is this one, the star, and then this is Al-Khawar. Okay, so this will be the place. So it's between the star and that dot. Okay, so if I measure it, okay, if I measure it, I get if I measure it, I get 10, 11, 12. I get about 13. So it's 13 millimeters. Okay. Then we need to do the calculation. We check the distance. So distance, we can use letter D for a distance. We cross multiply. If I cross multiply, D times 12, I get 12D equals to 13 multiplied by 50 is 650. Then we divide by 12. We divide by 12, and then D is equals to 650 divided by 12. Then I get 54. Then remember, this is now 54 kilometers. Okay, so when I do the calculation, when I use the scale, remember initially I measured the scale is 12 millimeters, it's the same as 50 kilometers. But when I measure the length between the two places, I get 13. Right, then from this one, the question is, a tour guide stated that Al-Khor is 45 kilometers away from Doha. So verify showing all calculation if this statement is true. You can see that the statement is not true because the distance is actually 54 kilometers. So you also have to indicate not true. Okay, because you would have indicated the calculations that the distance is actually 54 kilometers, not 45 kilometers as indicated. Right, so that was question number 3.5. Okay, then the next typical exam question, okay, that is question 4. It was taken from Mpumalanga, September 2022, paper 2, and it was question number 2. Right, then there we've got the map of a stadium. They say figure skating is a very popular winter sport in America. Angelique is training to become a competitive figure skater. She performs regularly at Greensboro Coliseum Ice Skating Rink in North Carolina, USA. Use picture to answer the questions that follow. So you have to use the picture to answer the questions that follow. Okay, then 4.1 is write down the number of zones. Write down the number of zones shown on the sitting plan of the ice skating rink. Okay, write down the number of zones shown on the sitting plan of the ice skating rink. So the number of zones, if you look at the bottom of the map, there you've got zones, okay, with different notations there. Okay, then you've got zone A, you've got zone B, you've got zone C, you've got zone D, you've got zone E. So there's actually 5 of them. So the number of zones are 5. The number of zones are 5. It was just a matter of counting, that's all, and then you write down the number. Okay, then the next one is identify the zone that has the least seats. Okay, identify the zone that has the least seats. So remember, we've got zone A. Okay, zone A, there's zone A. Okay, and then we've got zone B. You can see zone B, it's bigger. Right, zone B's are bigger. And then we've got zone C. Okay, we also have zone C, we've got zone D, and then we've got zone E. So in this case, they say identify the zone that has the least. So the least will obviously be this one, as zone A. So zone A is the one that has got the least seats. Okay, then the next question, it's Determine the zone to which the block numbers 101 to 107 belong to. Determine the zone to which the block numbers 101 to 107 belong to. Right. 101 to 107. Let's look at this. Here we've got 101, we've got 102, we've got 103, 104, 105, 106, 107. But the zone letters are not indicated. Okay, but if you look around, then you'll see that these numbers actually belong to zone B, because there is zone B around. They belong to zone B. It's just that the letters are not indicated there. So this one is zone B. That is number 4.3. Okay, then number 4.4. Calculate the total number of blocks in zone A and zone B. Calculate the total number of blocks in zone A and zone B. So it means they want to know the total number. What is the total when you add them together? So zone A, we have to count zone A. If I look at the A's, I've got 1, I've got 2, I've got 3, I've got 4, I've got 5, 6, 7, 8, 9, 10, 11. So zone A, I've got 11. And then what about B? For B, okay, I need to start counting. If I start counting from here, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. But these are not the only ones. So it must be 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So when I count, I started at this one. I went around until I get back to this one. So zone B is 32. Okay, zone B is 32. So the total will be 11 plus 32. Then I get, so it's 32 plus 11. Then that is 43. Okay, that is number 4.4. Okay, then the next question is 4.5. Give one reason why you think zone D tickets are the cheapest. Zone D, there we've got zone D are the cheapest. Okay, so for this one, you'll have to give your own relevant answer, your own reason that is relevant. Why do you think these zones will be the cheapest? Okay, it might be that the view is not clear, okay, from the stage. Okay, so actually when you look at the stage, you might not see properly, you might not see clear, or any other reason. Okay, so or maybe because it's very far from the stage, so that is why maybe it's the cheapest. So any relevant reason. So this one it can be because the view is not clear or very far from the stage. Okay, that will be one of the possible reasons. Okay, then the next question is taken from Free State, September 2022, paper 2, question 4. It was question 4. Then it's the elevation map. Remember, we spoke about the elevation map from the beginning. Okay, it's about the high and lows of the land. If you look at this one, you'll see that if the runners are running from one point to another, they're actually running up and down, because when you run from one place, it's at a lower level. When you go to the next one, it's at the higher level. Then you go down, up, down, and so on and so on. At some stages, you might find that you run for a longer distance on a flat surface. But in this case, it's about the high and lows of the land. So in this case, they say the elevation map with the distance chart for the Two Oceans Marathon is shown alongside. Use the map to answer the questions that follow. So the questions, Write down the total distance of the Two Ocean Marathon and the name of the place where it finishes. So there it started. These are the kilometers. Started from 0, and there you've got 55. And then the name of the place, you see the finishing line there, it's UCT. So it's UCT, that is the University of Cape Town. But they say how many kilometers? They didn't indicate the last kilometer there, so that is why they wanted to indicate. So here we've got 55, right? So for 55, then you can see the intervals here. Intervals here is 50, 55. So the next one, it's supposed to be what? 60. But you can see that it's not even the same as the other intervals. It's a little bit smaller. Okay, so you can't say from this point to that point is the same as from 50 to 55. Therefore, you can't say from 55 to this point, it's 60. It must be a little bit less. So for this one, we can estimate it to be about 57 or maybe 58. So it can be 57 kilometers. But definitely not 60, because if you say 60, you'll be meaning from 55 to this point is the same as from 50 to 55, and that will not be correct. So this one, we can estimate it to be about 57 kilometers. Okay, then 5.2 is what is the third highest point of the Two Oceans Marathon, and what is the height above sea level in kilometers? Okay, what is the third highest point of the Two Ocean Marathon? The third highest point. So the third highest, we're going to look at this. Which one is the first highest? Which one is the highest of them all? So obviously it's this one. Okay, and then if you look at the level, the second one is this, and then this is the third one. So this will be the third highest. This will be the third highest. So now the third highest, we've got the first highest, we've got the second highest, and this is the third highest. Then if you look at the place is Chapman's Peak. Chapman's Peak. And then they say, what is the third highest point of the two oceans, and what is the height? And then if I look at the height there, the height is about 180 meters. So it's 180 meters. But be careful, they say, what is the height above sea level in kilometers? What is the height above sea level in kilometers? So it means this one, we don't just write it in meters, but we need to convert it. How do we convert from meters to kilometers? How do we convert from kilometers? From meters to kilometers, we need to divide by 1,000. So if we divide 180 by 1,000, and this will give us 0.18 kilometers. 0.18 kilometers. So that is the answer for number 5.2. You had to answer two questions in this case. You had to give the name and also give the height, which must be in kilometers. Okay, now boys and girls, we're still supposed to do a lot of activities. Unfortunately, time is not on our side, but I think we did more than enough today. And then thank you very much for watching. And thank you again for tuning in. We hope that you have learned a lot, and then you are busy preparing yourself for the prelim examination that is coming. But once more, thank you very much for watching this lesson, and then I will see you next time. Goodbye.